Welcome to the SIEM crash course, rebuilt from the ground up for Microsoft Sentinel and Custo query language. If you've worked through the Splunk version of this course, every stop on the map will feel familiar, only now it's spoken in KQL instead of SPL. Over the next chapters you'll see what a SIEM does through Microsoft's Cloud Lens, how Sentinel's architecture replaces the forward indexer search head model with data connectors and a log analytics workspace, how provisioning differs from installing software, how data lands in auto-parsed tables instead of needing manual regex extraction, and how every core SPL command maps directly onto a KQL operator. We'll close with two hands-on hunts, DNS and HTTP traffic analysis, and a look at how Microsoft Sentinel turns a match detection into a working incident. Use the sidebar to jump around, or just press play. A SIEM, security information and event management, still does the same three things no matter which vendor builds it: aggregate data from across the environment, correlate it to spot patterns, and raise alerts when something looks wrong. That gives a security team one thing that's hard to get any other way: a 360-degree view of the network. Microsoft Sentinel is Microsoft's cloud-native SIEM, and Custo query language, KQL, is the read-only language that sits underneath it, and underneath Defender XDR and Azure Monitor as well. Where Splunk indexes machine data on infrastructure you own and size yourself, Sentinel indexes it inside a log analytics workspace that Microsoft runs for you, and you query it the same way whether you're hunting an incident or building a report. The concepts carry over one-to-one, only the engine and the syntax change. The reasons a SOC leans on this stack map directly onto the reasons teams leaned on Splunk. First, real-time detection. Sentinel's analytics rules run scheduled or near real-time KQL queries against incoming data and fire the moment a pattern matches. Second, streamlined incident response. Every matched rule becomes an incident with an entity graph, so instead of hand correlating alerts, an analyst opens one investigation and sees the whole picture. Third, compliance reporting. Sentinel Workbooks map log data against frameworks like PCI DSS, HIPAA, and GDPR the same way Splunk dashboards did, just built with KQL instead of SPL. And fourth, scalability, because it's Azure native, ingestion and compute scale automatically with data volume, so there's no capacity planning exercise before a busy week. Same four pillars, cloud native execution. Sentinel's architecture replaces three Splunk building blocks with three of its own. Where Splunk used a forwarder to ship logs, Sentinel uses a data connector, often paired with the Azure Monitor agent, to pull or receive data from a source. Where Splunk's indexer stored and indexed events, a data collection rule, or DCR, transforms and routes that data into a log analytics workspace, which stores and indexes it. And where Splunk's search head was the query interface analysts worked in, that role now belongs to the logs blade inside Sentinel, or Defender XDR's advanced hunting pane, both running KQL against the same workspace. There's no universal versus heavy forwarder distinction to manage and no single instance versus clustered deployment decision to make, because the whole pipeline is a managed Azure service. Data in, KQL out, that's the whole shape. Splunk sizing meant CPU cores, RAM, IOPS, and an MSI installer. Sentinel sizing means choosing a data tier and a retention window, because there's no hardware to provision at all. Analytics logs is the full price tier, fully indexed, available for interactive KQL queries and analytics rules, typically kept 90 days by default. Basic logs costs a fraction as much per gigabyte for high volume, low-value data you rarely query interactively, with a lighter query experience. Auxiliary or archive tiers exist purely for long-term retention and compliance, queryable only through search jobs rather than live KQL. Instead of an install wizard, you enable a workspace in the Azure portal, connect your data sources, and pick where each table lands on that spectrum. The trade-off shifted from hardware procurement to a cost per gigabyte decision made table by table. Splunk's search and reporting app came built in, with enterprise security as the SOC-focused add-on. Sentinel bundles that same split into one product, organized as blades in the Azure portal. Logs is where day-to-day KQL querying happens, the direct equivalent of search and reporting. Analytics is where correlation rules live, the equivalent of enterprise security's correlation searches. Hunting gives analysts a curated set of hunting queries and bookmarks for proactive investigation. Workbooks are Sentinel's dashboards. Incidents is the triage queue, and threat intelligence lets you import and match indicators of compromise against your data automatically. Nothing here is a separately licensed add-on the way enterprise security was. It's all included in the Sentinel workspace from day one. This is where the two platforms diverge the most. In Splunk, raw log text arrives mostly unstructured, and getting real value out of a custom source usually means picking a sample event and writing a regular expression by hand to extract each field. In Sentinel, a data connector and its data collection rule handle that parsing at ingestion time, before the data ever lands, so it arrives in a table with a typed, documented schema already in place. Device logon events already has timestamp, device name, account name, and remote IP as columns, no extraction required. You can still add ingestion time transformations in the DCR using KQL itself, to reshape, filter, or enrich a table before it's stored, but the default path requires 0 regex. The best practice inherited from Splunk still applies, though. Validate a new connector against a handful of sample events before trusting it at scale. Most of what you did in SPL has a near-exact KQL counterpart, and once these map, day-to-day querying stops requiring a mental translation step. Splunk's search command becomes KQL's where. Stats becomes summarize. Table becomes project. Top stays top, syntax barely changes. Dedup becomes distinct, or summarize with arg_max when you need the freshest row per key. Time chart becomes summarize by bin of time, paired with render time chart. Eval becomes extend, for computing a new column on the fly. Transaction becomes a combination of summarize and bin-based windowing, since KQL doesn't group sessions quite the same way. And lookup becomes either external data, for pulling in outside reference data, or a join against another table already in the workspace. Learn this table once and SPL muscle memory carries over almost completely. Every KQL query starts with a table name, then pipes data through a chain of operators, exactly like SPL pipes through commands. Starting from device logon events, a where clause bounds the time window and filters to failed logons, the same first move you'd make in SPL. Piping that into summarize with account, grouped by remote IP and account name, collapses thousands of rows into a shape you can actually read, KQL's answer to stats. From there, project renames remote IP and account name into report-friendly labels, and order by sorts the highest count offenders to the top. Filter, aggregate, shape, sort, 4 operators chained with the pipe character, and that covers the overwhelming majority of everyday hunting in KQL, the same way 4 SPL commands covered it in Splunk. Once a KQL query earns its place in your daily routine, the move is the same instinct as Splunk: don't retype it, save it. In the logs blade, running a query surfaces a pin to dashboard option that drops the result straight into a Sentinel workbook, Microsoft's answer to a Splunk dashboard. From there you can add more panels, tables, time charts, metric tiles, each backed by its own KQL query, arrange them on a canvas, and set parameters so viewers can filter by time range or entity without touching the underlying query. Workbooks save as JSON, which means they version control and share cleanly across teams. The payoff is identical to Splunk's. Instead of everyone rerunning the same investigation query by hand, they open a workbook and the answer is already there, refreshed on a schedule. Same investigation as the Splunk course, run entirely in KQL. Starting from device network events filtered to DNS-style queries, summarizing by remote URL and counting requests, grouped by the initiating device, surfaces exactly the same signal Splunk's top command would have found: one domain, one host, disproportionately more queries than anything else in the environment. In this workspace, a single device queried update-cdn-relay.net over 11,000 times in 24 hours, a volume no legitimate application produces, and a strong signal of command and control beaconing. Projecting device name, remote URL, and request count into a clean report, sorted highest first, hands off exactly the kind of artifact a Splunk table command would have produced, just written with summarize and project instead of stats and table. HTTP analysis follows the same pattern in KQL as it did in SPL. Working from device network events, or a proxy table if one's connected, the same HTTP fundamentals still apply: GET retrieves a resource, POST submits data, and status codes tell you the outcome: 200 for success, 404 for not found, 500 and above for a server-side error. Summarizing outbound connections by remote URL and counting them surfaces the busiest destinations, exactly what Splunk's top command against DST_IP used to do. Pairing that result with a threat intelligence join, matching remote IPS against an imported indicator feed in the threat intelligence blade, lets you separate ordinary business traffic from something that actually deserves a closer look, the KQL equivalent of pairing a Splunk lookup against VirusTotal. Splunk Enterprise Security turned a matched correlation search into a notable. Sentinel does the same job with an analytics rule: when its underlying KQL query matches, Sentinel generates an incident automatically, complete with a severity rating and, unlike a flat notable list, a live entity graph connecting every account, host, and IP involved. From the incidents blade, an analyst can change status, assign ownership, or add comments and tasks, exactly like triaging a notable in incident review. Opening an incident surfaces its entity graph directly, so pivoting from a suspicious account to every host it touched is a click, not a new query. Playbooks, Sentinel's automation layer built on Azure Logic Apps, can trigger straight off an incident, the rough equivalent of enterprise security's automated response actions. Same triage motion, native entity graph instead of a build-it-yourself investigation. That's the full arc, ported chapter for chapter from the Splunk course: what a SIEM does through Microsoft's lens, how connectors and a log analytics workspace replace forwarders and indexers, how provisioning a data tier replaces sizing hardware, how ingestion arrives pre-parsed instead of needing regex, the KQL operators you'll reach for daily and how each one maps back to its SPL counterpart, how a workbook replaces a dashboard, 2 hands-on hunts proving the syntax translates cleanly, and how Sentinel turns a matched rule into a fully graphed incident. The best next step is the same one that closed the Splunk course: hands-on repetition. Pull a sample table, write your own where and summarize chains from scratch, and keep the SPL to KQL cheat sheet open until the operators stop needing translation and just become the way you think.